Right, on to section 2.4, which we're going to be breaking up into two different parts. And we're going to start out by reviewing how to divide polynomials. So we're going to use long division to do that. I'll also talk about the remainder and the factor theorem. And then if using long division is not your thing, I'll also talk about synthetic division, which does work when you're working with some polynomials. So first of all, kind of need to go back to how do you actually do long division, because it's been so long since you've done this. Remember, you would take, if we take 1,587 and divide it by 32, we're looking at how many times does 32 go into 3? Well, it doesn't, so then we'd look at the 35 instead. 32 goes into 35 one time, and now here's where we multiply. We take 1 times 32, which is 32. We put that underneath the 35, and now I subtract. 35 minus 32 gives me a positive 3. Next, what I'm going to do is I'm going to bring down the next term, which in our case here is 8. And now I go, how many times does 32 go into 38? Well, it goes in there one time. Now 1 times 32 is 32, and once again we subtract. 38 subtract 32 is going to end up giving us 6, and then I bring down the 7. And lastly here, how many times does 32 go into 67? And it goes in there 2 times. And now 2 times 32 ends up giving us 64. And so then I subtract, and I end up with 3. Because I filled in all the place values up above, this 3 ends up being our remainder. And so we get our remainder of 3. So when you think about this, and when we did long division back in elementary, middle school, you are taking a dividend and you are dividing it by what's called the divisor. Once you come up with your answer, you're talking about the quotient, and sometimes you'll have a remainder that needs to be added on to this as well. So there's 2 different ways that we can write out our answer for long division. The way that you probably did it in middle school or elementary school was 112 with a remainder of 3. What we're going to be doing now is actually looking at the fraction form of leaving this, because you are getting a full 112 out of this, and then with that remainder is still part of 32, so we're going to be leaving it as that fraction. Now, when you're checking your work with long division, if you take your quotient, which in our case is 112, and you multiply it by your divisor, which is 32, and then by adding on your remainder, if your long division worked out correctly, you would end up with your dividend of 3,587. You take your quotient times your divisor, and that gives you your dividend, and then adding your remainder if you need to. So now we're going to take this long division and we're going to go into how do you do this with polynomials. So here I have 3x to the third plus 5x squared plus 8x plus 7, and I'm going to divide it by 3x plus 2. So where this all begins is I take a look at just this 3x. And I'm going to ask myself, okay, well, how many times does 3x go into 3x to the third? Another way of thinking about that is 3x times what would give you 3x to the third? And what we're going to end up here with is I'm going to end up with x squared. Because now when I multiply x squared times 3x, that gives me 3x to the third. X squared times 2 is going to give me a positive 2x squared. And so now what I can do is I can subtract, and my 3x cubes are going to go away. 5x squared minus 2x squared, because I'm subtracting there, is going to give me 3x squared. Now I take a look at this 3x again, and I ask myself, what times 3x would give me 3x squared? Well, the 3 is already there. I just need to multiply by 1x. And so now 1x times 3x, oops, I'm sorry, I forgot to bring down my 8. So I'm going to bring down my 8x before I do anything here. So now 3x times what gives me 3x squared? That's 1x. 1x times 3x is 3x squared. 1x times 2 is a positive 2x. Now I can subtract. 3x squares are going to cancel out, and here I'm going to end up with 6x. Finally, I'm going to bring down my last term here of positive 7, and now 3x times what gives me 6x, and that's positive 2. 2 times 3x is 6x. 2 times 2 is 4. And now I'm going to subtract, and I end up with 3. Because I have filled all my places up above, this ends up being my remainder. Up above here, I'm going to add a couple plus signs. And then my answer here ends up being x squared plus 1x plus 2 with a remainder of 3. And so now ways that we can write this out, or the way that I'd like us to write out, is 1x squared, which I don't necessarily need the 1x, 1. So I've got x squared plus x plus 2, and then plus, and then I have 3 out of 3x plus 2. So that remainder that we have here is going to be a part of that 3x plus 2 first. Now, how do you check your work once you come up with your solution? You take your quotient, multiply it by your divisor, and add on your remainder to this. So if I was to go ahead and check my work, I would take x squared plus x plus 2, multiply that by 3x plus 2, and then I would add on my remainder. And when I did that, what I would hopefully end up here with, and I will get the 3x to the third plus 5x squared plus 8x plus 7, and that is your dividend that we started with at the beginning right here. So taking your quotient, multiply it by your divisor, and add on your remainder. So what I'm going to do now is I'm going to go through one more example. Some of you might have got this down, so if you want to kind of jump ahead to the next part, you may do so, but maybe you just want to sit back and listen to it a little bit more. So here again, I'm going to divide. I'm going to say 2x. What can I multiply it by to get 4x to the third? And that's going to be 2x squared. And I'm going to multiply now, so I get 4x to the third and plus 2x squared. One thing that I think is really important when doing long division is that you keep columns, and that you have a column of your x to the third, column of x squared, x to the first, and your constant terms, just so that it makes things a little bit easier as you're working through this. So subtracting, my 4x cubes are going to cancel out, and here, because I'm subtracting, I'm going to end up with a negative 10x squared. A lot of times people always forget that we are doing the subtraction. Bring down the next term, which is a positive 2x. Now 2x times what would give you negative 10x squared? And that's going to be a negative 5x. Negative 5x times 2x is a negative 10x squared minus 5x. Go ahead and do our subtraction. Negative 10x squares are going to cancel out. 2x minus a negative 5x is going to end up giving me a positive 7x. When you subtract a negative, you got a positive. And then I'm going to bring down my negative 1. Now 2x times what gives you 7x. Now this one can be a little bit of a problem for some people because they're saying, well, 2 doesn't go into 7 evenly. So you got to think more fraction-wise here. 2 times what? So if I did 2 times x is equal to 7. So 2 times what equals 7. I would have to divide both sides by 2, so x would equal 7 halves. So what I'm going to be doing here is I'm going to be adding the fraction of 7 halves. Now 7 halves times 2 would give me 7x. 7 halves times 1 is going to give me 7 halves. And so now when I do my subtraction, my 7x's are going to cancel, and then here I'm going to get negative 1 minus 7 halves, which should end up giving me negative 9 halves. And so there's my remainder. If I go ahead and take I'm just going to move this all over here. So my solution with that remainder is 2x squared minus 5x plus 7 halves minus, and then I've got 9 halves divided by 2x plus 1. And what we could do here, and I'm not going to get too picky about it right now, is I could simplify that 9 halves over 2x plus 1 so we did not have a fraction in a fraction. But right now I just want us to focus in on just working through the division. Now, one thing to be real careful about is if you have a polynomial that you're working with division and it's missing terms, you're going to want to fill in all of those terms with zeros before you start your long division. So here I have x to the fourth, but I'm missing an x to the third, so I'm going to put 0x to the third plus 0x squared plus 0x minus 1. You're going to want to have those place values in so that you have got all of your columns that are going to work out very well for us. So just going through one more long division problem here. So x times what gives me x to the fourth? Well, that's going to be x to the third. Multiply, I get x to the fourth plus 2x to the third. And then I'm going to subtract. X to the fourths will cancel, and I'll get negative 2x to the third. Now I want to bring down the 0x squared. And by doing that now, we're going to look at x times what gives you negative 2x to the third, and that's a negative 2x squared. Negative 2x squared times x is negative 2x to the third minus 4x squared. And we're going to subtract. Negative 2x to the third minus negative 2x to the third is going to cancel out. Here I'm going to get a positive 4x squared, and we're going to bring down the 0x. So now x times what gives you 4x squared, so that's going to give us 4x. 4x times x is 4x squared. 4x times 2 gives you 8x. Subtract. I end up with a negative 8x. And the next part here, we're going to bring down the negative 1. Almost done. One last one here, where we're going to look at the x times what gives us negative 8x, which is a negative 8. And I get negative 8x. And then negative 8 times 2 is a negative 16. And we're going to subtract, and I end up with a positive 15 for our remainder. So my solution ends up being x to the third minus 2x squared plus 4x minus 8 plus 15 over x plus 2. Now in the next couple sections that we do get into, you're going to find that we are not going to have remainders because that's going to be one of our goals. So it's so right now we're just kind of playing around with those. Now the next thing that we're going to be looking at doing here is if you are not a fan of using long division, you also have another choice, and that is to use synthetic division. And however, synthetic division only works for when you are using divisors that are in the form of x minus k. So your leading term has to be of the first degree, and your leading term has to have a leading coefficient of 1 for what you're dividing by. Now you can change around the problem a little bit to get this, but it kind of then we have to change it back in the end of things. So long division we can use, and we will be using, but synthetic division is a bit of a faster way to do all of this. And also it's nice because you're not working with any variables and you're not working with subtraction, you're going to be working with addition as well. So synthetic division, how this works is you start with this little kind of backwards L, and inside that L is going to be the value of k. It's what you are dividing by here. And this is x minus 3, which allows for k to be a positive 3. So we're going to put a 3 here. Next, we're going to take all of the coefficients, okay, of our of what we're dividing by here. So we're going to take 2, negative 3, negative 5, and negative 12. And I'm going to draw a little horizontal line down here at the bottom, and here's how synthetic division works. We drop down the first term as 2, and now we multiply. 2 times 3 is 6, and rather than subtracting here, we're going to add. Negative 3 plus 6 ends up giving us a positive 3. Now we're going to multiply. 3 times 3 is 9, and now we add, which gives me positive 4. 4 times 3 is 12, and I add, and I get 0. The last value that's here is always going to be your remainder. There's your remainder. And then what you're left with here is your polynomial, your answer. And how we put in our x's here is if this is your remainder, this is x to the power of 0, this is x to the first, and this is x squared. So our final answer here is 2x squared plus 3x plus 4. And we would get that same thing if we were to use long division. So I'll go through another example using synthetic division again. So here I'm dividing by x plus 2. So that tells me that k is going to equal negative 2 because it's got to be in the form of x minus k. So I'm going to put a negative 2 up in the half of the box up here, and then I'm going to fill out my coefficients. Now, if you are missing any variables to the powers, we have to put a placeholder for it. So since I'm missing x to the fourth, I have to put a 0. Since I'm missing x to the third, I have to put a 0, and then I can fill in the remaining of 3, negative 4, and 1. Drop down the first term, which is 2, and then we multiply. 2 times negative 2 is negative 4. Add, and I get negative 4. Negative 4 times negative 2 is a positive 8. Add, and I get 8. 8 times negative 2 is a negative 16. Add, and I get negative 13. Negative 13 times a negative 2 is 26. Add it together, we get 22. 22 times negative 2 is a negative 44. Add, and I get negative 43. Now in this problem here, I have a remainder with the negative 43. But now the rest of my polynomial here, I've got x to the power of 0, x to the first, x to the second, x to the third, x to the fourth. So my final answer is 2x to the fourth minus 4x to the third plus 8x squared minus 13x plus 22 minus 43 divided by x plus 2. And there's my my synthetic division. So you may see that that's a faster and easier way to working this out. And great, wonderful if you can see that. Now next we're going to go into the remainder and the factor theorem, starting out with the remainder theorem. What the remainder theorem says is that if f of x is divided by x minus k, so you have that you're dividing by a polynomial of degree 1 and with a leading coefficient of 1, then the remainder is going to be the function of k, and that's what your remainder will be. What do I mean by that? Well, here our function that we're dividing, so f of x, would be 3x squared plus 7x minus 20. And what we're dividing here is by x minus 4, or x plus 4. So x minus k, in our case here, equals x plus 4, telling us that k is going to equal negative 4. So now to figure out what my remainder is, I could go ahead and do long division or synthetic division, or we can just take f of negative 4, and I can evaluate this. So take 3 times negative 4 squared plus 7 times negative 4 minus 20. And by doing this, and once I solve it, I end up with 0, which tells me that my remainder is 0. So just two examples here, taking the function f of x and dividing it by x minus 2. This is telling me that k would have to equal positive 2. So if I take f of 2, what I'm going to be doing here is figuring out what the remainder is. And so if I work this out, 2 times 2 squared is going to be 4, 4 times 3 is 12, 7 times 2 is 14. So once I do all of that, we should end up with 6 for our remainder. If I want to divide by x plus 1, this is telling me that k is going to equal -1. So take the function of -1, 3 times -1 squared, plus 7 times -1 minus 20. And as I continue to work this out, we should end up with -24. And this would tell me that I have a remainder of -24. Now, this long division is just getting us started to what's going to be, what we're going to be working on for the next couple days, and that's going to be solving polynomials and trying to find out all of the zeros that are possible. And what we're going to be getting into is using this idea of the factor theorem. Now, f of x has a factor of x minus k if and only if your remainder equals 0. If you ever struggled with factoring in the past, this will help break it down for you. We can use long division to help us find other factors if you know what one of the factors is. So in this problem here, we were taking our polynomial and dividing it by x plus 4. And the fact that we got 0 for our remainder here, this tells us that x minus 4 is a factor. That tells us that x plus 4 times something else is going to give us our polynomial that we started with. As we do our long division, we ended up with an answer of 3x minus 5. That is your other factor. Because as you check your answer and you take these two and you multiply them together, it gives you your original polynomial. So it's helping us break the factors apart. So I know that this has been a fairly long video, just kind of going back, but hopefully you're remembering all this from Algebra 2. If you have any questions on things, make sure you let me know.